Today will be our last topic on chapter 2, which on deep foundation, capacity and settlement on capacity and settlement of single pi and pi group, as well as the negative skin frictions. So I just want to refresh what we have learned in the early topic chapter 2 on the shallow foundations, and then what is the design requirement, and then the first criteria how we decide to use shallow foundation instead of deep foundations. Just to be reminded again is that when we have a deep ataupun depth more than 3 meter, so which need to carrying a load from superstructure, so that the shallow foundation is not anymore can be used or applied. So the pile foundations or deep foundation can be classified into two according to the design and construction. For example, first one is a driven or displacement pile, which are usually preformed before being driven, jacked, screw or hammered into ground. And then the second method of constructions or installation is a board or replacement pile, which require a hole to be first bored into, which the pile is then formed, usually of reinforced concrete. So by having these two definitions, I hope that you remember last Friday talk, the speaker also shown to you the method of installation by having a hammer and check in, and then less block on the ball pile. But I hope that you can differentiate between these two piles, whether you have the driven piles or the ball piles. And if you look at the pile categories according to the load carrying capacity, we can see that the pile can be classified according to the end bearing and also the skin frictions. But somehow the pile can have a combination between end bearing and friction resistance. So the end bearing piles is the pile act as a laterally restrained column, so the load being transmitted to the two and resisted by the bearing capacity of the soil. Meanwhile, friction piles is the load is transmitted to the soil through the additions of frictional resistance along the shaft of the piles. So by looking back to this image, okay, by looking to this image on the differentiation between the skin and also the end bearing pile, you may see that its function may be different according how it's carrying the load. For example, if you look at to this one, it is the end bearing where the load is transmitted at the bottom of the hard rock layer. Meanwhile, for the skin frictions that you can see how the load carrying capacity will be transmitted through the frictions of the soil and pile itself. So today we're going to talk on the ultimate bearing capacity analysis of single pile and group pile. Before that, looking to this formula, the symbol that define to ultimate bearing capacity of the single part, as you can see here as a QU, ultimate bearing capacity equal to the QP or QB is then to the end bearing capacity plus with the skin frictions capacity ataupun resistance. So having a cylinder pi embedded into the ground, which the D is the embedded length, and at the bottom of the pile is the end bearing ataupun base bearing capacity QP, or QB is equal to the QP AP, and then along this the pile shaft that we have a skin resistance as a QS, which equal to the F times AS. So the F is the unit frictional resistance, AS is the shaft area. So how do we get the AS and AP according to the size and shape of the pile? For example, if you are applying a circular pile into the ground, so the area of the bottom pile, the cross-sectional area of the bottom pile will be a pi d square over 4 because you have a circular pile. And then the area, the shaft area of the circular pile will be pi BL. So maknanya kita akan multiply antara the perimeter length of the pile BL ataupun DL darab dengan pi. However, if you have a square pile where you can see that the cross-sectional area of the square pile is B times dengan L, meanwhile for the shaft area of the square pile is 4 times dengan BL. So there's differences if you look at closely when you are having a different size and shape of the pile in order to determine AS and also the AP. Because when you have questions in the formula, basically you only have a general equations. So the term QS, QB, FAS and AP must be determined by yourself or by you memorizations on the formula. Okay, the next one showing to you a stress distribution at the bottom of the pile along this shaft resistance according to the different researchers. So that I hope that you can have some reading on this part. But importantly, kalau kita tengok in our analysis, basically we're going to consider from the tertiary and Meyerhof concept. Yang ni pun I dah explain. Okay. Okay, the combinations of friction piles and cohesion piles. So somehow we need to combine between end bearing pile and also the skin pile when you have some structures that carrying different loads, for example, vertical loading, horizontal loading, and moment and moment. So for example here, it can be applied or can be used as a ball pile which are provided with a bell, have a high tensile strength and can be used as a tension pile. So the applications of the ball pile here, you can see that at the bottom of the pile is not a straight length. Now you can see a bell shape. So the functions of the combined loadings atau load carrying capacity of the piles ni bergantung kepada its functions near the offshore ataupun dekat bridge piers ataupun di kawasan lain lah. So the pile actually can carry load from vertical, horizontal dan juga moment. So the complex analysis will be when you have a pile subjected to all these combinations loading. That's why it says that the analysis of piles subjected to lateral and moment loading is more complex than simple vertical loading because of the soil structure interactions. So maknanya kalau you look at to the application, biasanya dekat offshore structure lah yang paling critical, yang mana sebab dia adalah open area dan loading yang dia dapat tu dalam bentuk lateral force, moment dan juga vertical. Okay, from the static approach, in order to calculate the ultimate bearing capacity of single pile is QU sama dengan QB plus QS, and also we have a W, but this time the W can be neglected. What is the W? W is the weight of pile minus dengan weight of soil displaced. Tapi kalau kata you are using a steel pile, so the W need to be counted in the analysis. Okay, looking to the left side figure here indicates to you a normal situations or the normal capacity that existed along the pile penetrations. So once we apply or having an ultimate bearing capacity that penetrate into the soil, into the ground, there is a resistance skin frictions along the pile shaft upward directions to the penetrations, and also we're going to have the end bearing capacity at the heart stratum of the pile. So you akan nampak later on when we call it as a negative skin frictions that we will explain later. Okay, yang ni adalah similar explanations on the first concept, the formula from the static approach. So not to forget also, bila kita design pile foundation, we can estimate the allowable bearing capacity by having a factor of safety. Sama ada you are using the partial safety factor ataupun you are using the overall safety factor for shear failure. In terms of the design, dia masih lagi sama. Kita nak pastikan our structure safe in terms of the factor of safety against the shear failure. So the allowable bearing capacity QA can be estimated from the QU bahagi dengan FOS. So QU sama dengan QB plus QS over F. Or you can calculate allowable bearing capacity on the partial value such as QB bahagi dengan FB plus QS over Fs. Okay, we go to the first one on the static analysis approach for the piles in cohesive soil. So the piles in cohesive soil can be differentiated in situations or conditions of the soil itself ataupun dalam this particular matter is a clay. So the clay can be formed in a total stress analysis ataupun can be analysed as an effective stress analysis. So for example, through the alpha method, which is more applicable in the total stress analysis for short-term stability, it's only for clay yang mana the addition factor unit F is equal to alpha darab dengan C. The C is the cohesive strength of undisturbed clay. So you can see that from here, the first static formula for ultimate bearing capacity of the pile is the QU sama dengan QB plus QS. So you can see that the QB, since we have the pile in clay, so you akan nampak QB sama dengan CU and CAB. Meanwhile, the QS is equal to the summation alpha average undrained CU times dengan delta AS. So it is says that the recommended value NC is a 9 for intact clays and 6.75 for fissured clays. So the addition can be taken in around 0.45 to 0.3 according to the soil type lah. Kalau kata you ada soft clay ataupun normal consolidated clay, or you may have over consolidated clays. Okay, delta AS is the shelf surface area within the given layer of UD and average undrained strength along the pile shaft. So yang ni yang kita akan tengok nanti contoh lah macam mana kita nak determine the average CU ataupun CU. Okay, the second method for clay and also applicable for sand, we call it as a beta method. So in the beta method, it is analyzed for effective stress analysis, applicable for short and long-term analysis. Kalau untuk clay ni, dia lebih sesuai untuk long-term analysis lah. So the replacement from alpha to beta, where the beta is a K not tangent delta, that is 10 to the beta. So kalau you elaborate lebih tu, you akan nampak lah the QB is a CU and CAS, AB plus dengan QS, which K not average overburden pressure tangent delta times dengan AS. So the addition factor beta in around 0.25 to 0.4. So masih lagi sama. Yang berbezanya kat sini lah average effective overburden pressure. So we're going to consider the average overburden pressure at the mid layer of the depth ataupun at the center of the pile length. So that's when we are considered the effective overburden pressure. And the last method that is suitable for piles in cohesive soil in order to estimate the bearing capacity of the pile by using the lambda method. So the lambda method can, if you see from here, is the QS sama dengan lambda times average overburden pressure plus 2CU times dengan AS. So the CU is a mean undrained shear strength, and this is for phi equal to 0. So kalau phi equal to 0, dalam this time you akan nampak yang mana kita ada purely cohesive clay. Okay, the next slide explains in details how the situation in the clay can be differ from using alpha method ataupun menggunakan beta method. So remember the characteristic of the cohesive soil ataupun clay, it can be acting like the material itself is having low permeability, so that bila clay in undrained conditions exists at the time of loading, but have shown the dissipations of excess pore pressure takes place fairly quickly. By the time the piles is fully loaded, conditions may be near to being drained. So dalam keadaan undrained condition ni, bila you letak beban, the dissipations of excess pore water pressure is very fast to happen, and somehow it's difficult to measure. So that bila yang ni yang berlaku ataupun the clay in undrained condition, so kita akan analyse the pile capacity from alpha method. Tapi bila you pergi in sometimes yang mana the excess pore water pressure can be measured or developed, so the undisturbed cohesive soil now is in drain conditions. So it is estimated in the effective stress analysis. So ini untuk alpha method lah. Sama explanation tadi tu. Okay. So yang ni dia bagi idea lah macam mana kita nak dapatkan the value of alpha at the average CU. For example, kalau kata sebab sekarang ni you akan ada upper dash line dengan bottom dash line. Yang kita nak dapatkan the value of alpha at the average of line, yang mana full line kat sini. So kalau you ada average undrained condition is 200, so the alpha is around 0.26 lah, for example. That's the idea if you can get alpha from a graph. Ataupun alpha can be determined from these simple empirical equations. For example, kalau you ada undrained condition less than 25 kPa, so it is recommended alpha sama dengan 1.0. Ataupun undrained condition in range 25 to 75, this is how supposedly you calculate the alpha. Or you can have the CU more than 75, so that alpha is 0.5. Okay, just now we talk about on undrained conditions. So just tadi pun saya dah selit sikit pasal drain condition ataupun effective stress analysis. So effective stress analysis menggunakan beta method is the condition where the excess pore water pressure that develops when piles are driven in saturated clays gradually dissipates. So the unit frictional resistance F for the pile can be determined on the basis of the effective stress parameters of the clay in the remodeled state. So you can see now the beta ni kalau ikutkan in any methods pile in clay dan juga sand, dia boleh guna pakai. The only thing is that nanti dekat bahagian sand dia akan bagi tahu lebih lah data ni berapa nilai dia. Untuk clay, sebabkan clay ni dia tak ada addition sangat, so this time data is not mentioned. It just said that kalau you nak calculate K0, it can be calculated from the formula 8.39 ataupun 8.4 bergantung kepada the stress history of the clay. Sama ada you have normal consolidated clay ataupun you ada over consolidated clay. How do you determine this one? According to the ratio between pre-consolidation pressure to the present overburden pressure. So kalau you ada OC, the ratio is equal to 1, so kita boleh kata normal consolidated clay lah. Kalau you ada ratio more than 1, so it is OCR. So once you get that one, you kena tahulah yang mana formula is suitable to calculate the K0 for drain condition in cohesive soil. Okay, the last method for estimate bearing capacity QU in the clay menggunakan lambda method. So now the only thing is that you can see the delta ni multiply with the average overburden pressure plus dengan 2CU times dengan AS. Okay, ada soalan tak? So dalam this method lambda ni, it shows you that if you have a pile that embed into few layers which having a different properties of the clay C, you akan nampak the C for the first layer may be less compared to the middle, or somehow at the third layer dia akan berkurangan. So, but ideally it says that the stress will be increased by the depth. So macam mana kita nak dapatkan nilai average CU dan juga effective stress kalau you have this kind of problem and you need to estimate through the lambda method. So it shows that this is how you can get the mean CU dan juga mean effective stress. Okay, we have touched on the pulse in clay ataupun cohesive soil. Now we go to the pulse in cohesionless soil. So the pulse in cohesionless soil, kalau you look at to this one, the first term will be similar, which is QB plus dengan QS. And then the QB is extended as AB times dengan QB plus dengan summation AS QS. So the AB is the area of the pile, kemudian QB ni adalah effective sigma naught and Q. And then the AS ni masih lagi the shaft area of the pile. QS ni adalah KS tangent delta. So you can see that this is what I said, yang mana beta method ni dia boleh guna dalam cohesionless soil dan juga cohesive soil. Okay, tadi kalau you tengok untuk clay, there is no some definitions on the delta, tapi untuk sand ataupun cohesionless, the delta is the angle of friction between the pile and the soil. So how to determine NQ? NQ can be obtained from having the relationship internal friction angle with the ratio L to B. So kalau kata length ni is embankment depth, P is the diameter of the pile, contohnya 70, kemudian fee awak 30, so you boleh tariklah daripada sini, kemudian you pergi ke sini untuk dapatkan nilai NQ. Okay, untuk skin friction coefficients, dia bergantung kepada material of pile. Ada yang material made from concrete ataupun made from steel. So, in terms of the sand itself, dia bergantung kepada relative density. So, the relative density of the sand can be seen from the granular or the size of the sand. So in that way, we can classify sand sama ada dalam keadaan loose sand ataupun dense sand. For example here, if you are using concrete piles which embedded in the loose sands, so that the beta S can be taken as a 0.34 kalau you have the internal friction angle 25 degree. So kalau kata you want to ensure is it true or not, you can substitute baliklah nilai dalam ni. KS contohnya 1.0, delta 0.75, darab dengan 25 example. And then can you get the answer 0.34. So ini adalah contoh dia lah. Other researchers says, for example, Brom 1966 also recommended the delta value and KS for different material pile type. For example, steel, concrete ataupun timber, the KS can be found from this value. So you boleh nampaklah delta nilai berapa, kemudian KS untuk loose berapa and dense berapa. Okay, we go to the example here for undrained analysis. Contohnya lah, kalau kata you ada satu single pile embedded in single layer of soil and the pile diameter of 400 mm and the pile length is 6 meter is to be installed into a deep deposit of clay. So the clay has an undrained shear strength of 180 kPa at a depth of 6 meter and average undrained shear strength of 120 kPa over the depth 0 to 6 meter. Okay, the NC is a 9, alpha is a 0.6, so you need to determine the ultimate bearing capacity of the pile. Okay, from the informations, bila you sketch the punya image, you can see clearly how it is because when you read, you found that there are two CU value, 180 dan juga 120 kPa. So masa bila kita nak masukkan CU untuk QB dan juga CU untuk QS sebab dalam formula dua-dua tu ada CU. Satu untuk base, satu lagi along the shaft. So bila you baca balik, it stated that the clay has undrained shear strength of 180 at the depth of 6 meter. Maknanya pada kedalaman 6 meter, the undrained cohesion is a CU 180 kPa. So meaning that 180 kPa is the depth where the bottom of the pipe embed ataupun dia tertanam di situ. Meaning that 180 ni kita akan masukkan as a end bearing capacity in the QB. So NC sama dengan 9 sebabkan pi ni adalah circular, so kita boleh calculate dia sebagai pi d square over 4. Thus the QB, the end bearing capacity is a 203.5 kPa. Okay, seterusnya untuk average undrained cohesion, dia dah mention the average undrained strength of 120 over the depth 0 to 6. Maknanya daripada 0 meter sampai 6 meter ni average CU dia adalah 120. So automatically giving you the idea untuk QS kita akan masukkan 120 dalam this term. Dan alpha sama dengan 0.6. AS is the pi DL. L is the embedded length. So you akan dapatlah 542.6 kPa. And then we total up antara QB dan QS. So you have the 746.1 kPa. Yang tadi untuk undrained analysis. Now we go to drain analysis. For example, kalau you look at to this drain analysis example, we have a multi layers of soil yang mana at the upper layer is a field from 0 to 3 meter, and dense gravel from 3 to 7 meter, and 7 to 8 for clay ataupun the second condition 7 to 11 meter. So apa yang dia nak bagi tahu pada awak, it will be different QS for layer 1, layer 2 dan juga layer 3, and also the end bearing of the pipe. When you look at to this one, the end bearing of the pipe is located in the clay. So apa yang kita perlu buat ataupun kira, kita akan pakai QB from the clay, it's not from the sand. Walaupun in the upper two layers are sand, but you have to see kat mana bottom part tu berada. Dia berada dekat second layer ataupun dekat third layer. For this example, the bottom part is located at the third layer. So when you go further untuk doing the analysis, we can see that first of all kita akan estimate QS dulu for field. So the formula is the AS, KS, average overburden pressure, tangent delta. So dalam this case, area dia adalah pi DL, kalau ikutkan DL. Ataupun L ni merujuk kepada thickness of the pile in that particular layer. So now dia punya depth is 3 meter. Mana dapat 3? 3 tolak kosong lah. Kemudian the overburden pressure ni kita akan estimate at the mid center of the 3 meter. So 20 ni adalah unit weight of the soil times dengan height of the layer is 3 meter bahagi dengan 2. Tangent 0.75 times dengan 30 darjah. And then for the next one, untuk gravel, the stress and the overburden pressure will be increased from the upper part and also to the second layer. But now the second layer must be counted or calculated at the mid center. So apa yang you akan nampak kat sini adalah 60 ni is coming from the upper layer field, yang mana 20 darab dengan 3, you akan dapat 60, campur dengan unit weight for second layer is 21 times dengan depth kat sini untuk layer kedua adalah 4, 7 tolak 3 dapat 4 meter. Now again we have to measure at the mid center of the 4. So bahagi 2 lah. So kita akan dapat 21 darab 4 bahagi 2 campur dengan 60. So this is the overburden pressure at the mid of the second layer. So you can have the net QS is 632.1. Okay, for the clay, untuk QS clay, yang ni dalam keadaan alpha method, sebab dia dah bagi maklumat alpha kat sini, iaitu 0.6, the addition factor 0.6. So the average CU, kenapa dia kena tambah antara 120 plus dengan 145? Sebab sekarang ni pada 7 meter nilai CU adalah 120. Pi ni berakhir pada 8 meter dengan nilai CU adalah 145. So you kena jumlahkan bagi 2 sebab nak dapatkan dia punya average. So darab dengan area of the shaft pi dl. Panjang dia adalah 1 meter untuk clay ni. So you akan dapat QS sama dengan 124.9 kilonewton. Untuk 9 meter ni saya tak cover lah, dia lebih kurang sama dengan 8 meter. So the total for ultimate bearing capacity at 8 meter end, so you akan dapat 1071.8, yang mana yang ni datang daripada fill, yang ni datang daripada gravel, yang ni datang daripada clay. So we total up and then the QB is only 1 since we have end bearing capacity 1. So kita dapatlah 1071.8. Okay, itu berkaitan dengan single part. Okay, yang ni pun contoh yang lebih kurang samalah. Cumanya dia lebih kepada macam mana nak dapatkan Q design ataupun allowable bearing capacity kalau you are given the factor of safety. So factor of safety ni dia bergantunglah, kalau dulu shallow foundations kita boleh consider as a 3 kan. Tapi dalam deep foundation it can be 2 to 2.5 lah. So you can see from this example. Okay, the negative skin friction. As I explained, normally bila kita penetrate pi into the ground, so kita akan nampak the skin frictions will resist the movement of the pi penetrations in opposite directions. Kalau kata pi you moving downward, nanti skin friction yang terhasil tu dia akan bagi daya ke atas. But in opposite directions, in opposite situations of negative skin frictions, yang mana you akan nampak bila kita penetrate pi downward, so negative skin friction ni akan menghasilkan addition factor in the same directions of the pi penetrations. So apa yang berlaku kat sini, the value of the shaft resistance develop between the pi and soil in a downward direction and results in the increase of the load on the pi. Maknanya kalau tadi you akan nampak perbandingan antara nilai QB dengan QS, ada yang QB besar, QS kecil kan. So now kalau kat case negative skin friction ni kita boleh nampak yang mana QS ni increase the load of the pi. So dia akan bagi nilai lebih besar lah. So it's developed when piles are driven through a layer of free material which slowly compacts or consolidates due to its own weight, ataupun the layers underlying the field consolidate under the weight of the field. Okay, yang ni it says that you can see the pi penetrations and then negative skin frictions develop, where this is the time you're going to have additional load along the shaft. So bila ada this kind of additional load of the shaft, automatically the calculation will be different. So the expression for load carrying capacity of pi subjected to negative skin friction as what you can see from here, iaitu QBAB masih lagi sama. So the only thing difference is that from here, summation loading skin plus dengan ASR. So the next subsection for today is on the pile group dan juga settlement lah. Sebelum kita cerita pasal pile group, you need to know the efficiency of the pile group. The efficiency of the pile group can be estimated from the ultimate group load bahagi dengan number of pile darab dengan ultimate individual load. So this is how we can determine the efficiency number. And then if you have more than one pile, more than one single pile, in a way to combine all few numbers pile in one sections ataupun one structure, so we're going to integrate all these piles using a pile cap. So kalau you nampak kat sini, pile cap ni adalah satu struktur yang memegang beberapa pile yang mempunyai diameter yang sama lah. The only thing different is that dia punya distance ratio, spacing to spacing, pile tu berbeza untuk menghasilkan BG dan juga LG. Apa pentingnya BG LG ni? Untuk memberi ultimate bearing capacity of the pile group. So you have to know how to estimate the LG dan juga BG. It also give you some idea the arrangement of piles in the group. Contoh, Kalau you ada 4 piles, number of piles 4, so it is recommended to arrange in this positions lah. Kita ada dua, kemudian dua in first row, dua lagi in the second row. So kita akan pakai square pile cap. And then kalau you ada 5 numbers of piles, so it is recommended to have these positions of piles, dua in the first row, and then second row will be having 1 pile, and the third row will be having 2 piles, so that we can produce a circular pile cap. So the circular pile cap ataupun whatever piles, it depend on the piles number dan juga arrangement. So dia ada details calculations lah untuk you estimate the positions ataupun the arrangement of the pile. So the pile can be, the pile cap ni ada yang placed on the ground ataupun they can be hanging lah ataupun freestanding pile. The freestanding pile ni akan memberi impact to the arrangement of the pile. Okay, yang tu berkaitan dengan pile group. Apa yang you akan belajar di akhir lecture ni adalah settlement jugalah. Settlement of the pile group. Settlement of the pile group is more crucial compared to the single pile. So that's why nanti you akan nampak how the settlement of the pile group can be estimated as a block failure in order to determine the settlement of the pile itself in terms of the stress increment delta sigma z. Here we go in details. So the bearing capacity of the piles is usually placed in a group with center to center spacing, typically between 2 and 5 shaft diameters. So the ratio of the average load in the pile group to the ultimate single pile load is referred to as efficiency of the group. So yang saya beritahu tadi lah. Kalau you nak tahu efisiensi dia, you kena tahu dululah ultimate bearing of the pile group bagi dengan number of pile. Contohnya kalau tadi kita ada 4, darab dengan ultimate individual load is 1000 and darab dengan 4 darab dengan 1000, so you akan dapatlah what is the right here, and then you bahagi dengan ultimate group load, you akan dapat the efficiency of the pile group. Yang ni benda yang sama tadi for explanations. Okay, pile groups in the cohesionless soil, when you are having a driven spikes into sand, so the relative density will increase and thus the group bearing capacity may be greater than the sum of the individual capacities. However, for design purposes, the efficiency is taken as 1.0. In the case of ball piles in sand, the efficiency is lower because the shear zones of adjacent pile overlap, giving values of efficiency as low as 0.6. So piles in cohesive soil, pile group in cohesive soil, to estimate the ultimate bearing capacity, the equation is modified as below, iaitu NC CU BGLG plus dengan average CU 2D times BG plus LG. So it says that if the spacing in group is 2 to 3 times the pile diameter, so the efficiency will be about 0.7. So the failure mode is likely to be a block failure. So the term here ataupun the block failure is important. Explain to you what's the conditions of the pile group itself and how does it will be affect to the settlement calculation. Okay, yang ni dia tunjuklah macam mana yang kita katakan kalau you ada length of the pile cap is a L, kemudian width of the pile cap is a B, and then you have the length of pile group and then width of the pile group. How do you get the value of the QUB for group lah, dan juga QUS for group pile. Okay, this is one example yang mana you have a 4 friction piles in cohesive soil. So the diameter of each pile is a 0.6 meter, 0.5 meter, and center to center spacing is 2.5, and the NC is a 7.0. So you are asking to estimate ultimate bearing capacity of the group pile, individual pile, dan juga estimate the Q equivalent. So the pile cap length width is a 3.5 by 3.5, and the spacing pile to pile is center pile to center pile is 2.5, LG is a 2.5 plus dengan 0.25 plus dengan 0.25. So you akan dapatlah 3. Undrained coefficient is 80 kilonewton at the 20 meter depth. Diameter of the pipe is 0.5. So using the alpha method, kita akan dapat the ultimate bearing capacity of the single pipe is 1100. So at the 20 meter depth, the value of CU is 80. And the average of the CU from the 0 to 20 meter is 40. And then area of the shaft is pi dl. It's not pi sebab dalam this case is sepatutnya 0.5 area base. Dia bukanlah sepatutnya. Dia dalam keadaan square pi lah sepatutnya ni. 4 darab dengan 0.5 darab dengan 20. BL. 4. The side length of the pipe. So the QU is 1100 kilonewton. Seterusnya, to calculate the ultimate bearing capacity of the group pipe. So BG sama dengan 3.0 meter. LG is 3.0. So yang ni sepatutnya L lah. Dia bukan BG. And the average undrained coefficient is 40 kilonewton. So the group ultimate bearing capacity of the group pi is 14,640 kilonewton. So you substitute balik dalam this formula. Depth, embedded depth is 20 meter. BG and LG is 3 plus 3. CU is 40 along the depth and along the pi shaft is 40. At the end of the pi is CU sama dengan 80 and C7, BG3, LG3. So you akan dapat 14,640. Okay, next question asks what is the efficiency of the pi group. The efficiency of the pi group sama dengan 3.33. So ultimate bearing capacity for pi group is 14,640 bahagi dengan 4 pi darab dengan 1,100. So kita dapat 3.33 lah. Okay, for initial loading from the pi group is estimated as 1,626.67. So ini adalah keadaan yang mana kalau kata pi group tu menghasilkan block failure, iaitu 2/3 daripada D dia. So you akan nampak the failure of the pi group in the block failure. So what we want to estimate is a Q equivalent, loading equivalent at this particular depth from the 2/3 D. So 2/3 D sama dengan 13.33 meter. So the L1 is LG plus dengan 13.33. 13.33 ni adalah 13.33 ni adalah depth yang kita measure from this end bearing sehinggalah block failure distribution. So campur dengan LG 3, so kita akan dapat 16.33. Same to the B1. So now the area of the equivalent is 16.33 times dengan 16.33, you akan dapat 266.67. Thus, the Q equivalent at the block failure sama dengan 54.9 kilonewton per meter square. So apa yang saya explain kat sini is part of the calculation to estimate the settlement lah. Lepas ni you akan nampak how does the settlement is being calculated for the pi group. Okay, contohnya kat sini lah you akan nampak. So the settlement of the pi group involves coefficientless and coexisal will be greater than due to n individual part. So in order to estimate the settlement, it is usually to consider an equivalent rod located at the depth of 2/3 where D is the embedded depth of the part. So just now calculations is actually showing to you how to estimate the Q equivalent at the first place before we can have the next calculation on the settlement value itself. So the area of the equivalent rod, Q equivalent, is determined by assuming that the load spreads from the underside of the pi cap in the ratio of 1 horizontal to 2 vertical or whatever it is given. So the settlement is then calculated by conventional means. So ini yang it says that you considered sebagai the equivalent cross-sectional area from the 2/3 of the embankment depth is the ratio 1 to 2. 1 horizontal, 2 vertical. Okay, the settlements, sometimes a pile group may be embedded above a soft-clay layer and transfer sufficient load to it to cause consolidation settlement. To estimate the settlement, the full design load is assumed to act at the depth of 2/3 L, where the L is embedded depth of the pile, and the load is then distributed in the ratio of 2 to 1. So the increase in vertical stress at the depth Z is given by Q allow ultimate bearing capacity of the pile group QAG bahagi dengan PG plus Z times dengan LG plus Z. Z ni adalah kedalaman kat mana kita nak estimate settlement ni. Kalau you tengok kat sini, Z ni kita akan ambil daripada 1/3 from L, yang mana lepas you dah kira 2/3 ni, so 1/3 from L sehinggalah the mid center of the soft clay. Itu yang kita panggil sebagai Z. So kalau tengok dia punya stress distribution dia in 1 to 2 dengan condition failure in a block failure. So the load transfer from this point, this particular point for the pile group. So tadi kita dah estimate 2/3 L and then the remaining in order to determine the increment of the vertical stress at the center of the clay layer as given here. So, apa pentingnya bila kita calculate delta sigma Z ni? Delta sigma Z ni, it is used to calculate the settlement of the clay. So, settlement is equal to MV darab dengan delta sigma times dengan H. MV is a coefficient of volume compressibility. So, remember balik dalam topik consolidation in soil mechanics, you ada MV, kemudian you nak dapatkan settlement tu, you kena tahu nilai delta sigma, and then you kena tahu the thickness of the soft clay layer, H berapa, okay, barulah you dapat nilai settlement. Okay, yang ni lebih jelas lah berbanding yang tadi tu, so we can see that from the top of this one, 2/3 from L, and then the load is transferred and this the distribution stress in 1 to 2, and it is having softly at the bottom part. So now the estimations of the settlement due to the pile load can be found from this one. Dapatkan dulu delta sigma Z, baru you boleh masukkan dalam this formula. So consolidated settlement of the clay layer is given by these equations. But somehow, the settlement also can be estimated from the second equation here. Kalau you tengok dekat bahagian bawah ni, kita ada satu lagi equation, iaitu primary consolidation settlement sama dengan H0 over 1 plus E0 CC log sigma C over sigma 0. H0 is the initial thickness of the soft clay, E0 is the initial void ratio, CC is the compression index, sigma C is the pre-consolidation pressure, initial sigma naught is the initial overburden pressure. Okay, dalam contoh seterusnya, dia tunjuk pada anda macam mana the load being transferred from the pile group dengan slope angle is a 1 to 2, 1 horizontal to 2 vertical, and how it is estimated to have the Q naught and then the Q equilibrium, the Q equivalence until to get the Z. So Z is 8.5 meter. So apa tujuan dia estimate yang ni lah untuk dia dapatkan the Q equivalent. The Q equivalent is actually the initial ataupun the stress increment at from this pile group. Okay, daripada sini 235 kN per meter square ni is there something that it says that the stress increase after apply a loading. Contohnya apa? Kalau you tengok pile group kita is embed on the soft clay. Kemudian you want to estimate the settlement at the point A. before you apply loading, the initial stresses is 83.5. Lepas you dah kenakan tegasan ataupun lepas you dah letak file group tu, settlement akan berlaku dan dia akan ada penambahan dari segi nilai effective stresses. So the final stresses after you apply loading can be estimated from here. Sigma C sama dengan effective sigma naught plus dengan QEQ. QEQ ni is the stress increment after you apply loading as a file group. So you can see that the sigma C is 318.5 kN per meter square. Finally, we can estimate the primary consolidation settlement by substitute into these equations. So you akan nampak balik lah, the initial thickness of the clay layer is 3, and then the initial void ratio is 0.852, and then the compression index is 0.33. So that you nampak lah sigma C 318.5, sigma naught is 83. So the final answer for settlement is 0.311. So it's a bit complex lah compared to single pile ataupun shallow foundation settlement. Tapi kalau kata you go through one by one the estimations of the pile group in the soft clay, and then how come it give the stress distribution to form in the settlement calculations. Kemudian macam mana you nak calculate for the BG and LG shown here from this example. Okay, do you have any questions? Ada soalan tak?
Tak ada, madam.
Okay, dalam final exam, tak silap saya, soalan ni dia akan tanyalah untuk final exam awak. Sebab final exam kita tak tanya lagi deep foundation, kita hanya cover untuk shallow foundations. So dalam deep foundation ni, it can ask you many things lah. For example, ultimate bearing capacity for single pile, and then pile group, the efficiency of the pile group, and lastly is a settlement. Ada satu part yang mana I'm not covered, such as pilot test lah. Pilot test ni is a way to show you how you can estimate the field data result to have the calculations for ultimate bearing capacity. Maknanya kita estimate ultimate bearing capacity from the field data, and also from the pilot test ni, kalau you tengok dia akan bagi you some kinds of the reading on the settlement, load versus settlement. So yang tu yang saya bagi awak untuk pelepasan lah through your own activity dan juga reading. But the critical part dalam deep foundations yang tu lah, you know how to estimate single pile ultimate bearing capacity in the clay ataupun in the sand, and then you know how to estimate ultimate bearing capacity for pile group, and the last one is a settlement. So take your time to have this kind of example from this note, and then go back to the learning activity first in topic 1, in topic 2, yang mana tak silap saya pada minggu tu there are 4 videos attached in the learning activity. For the first and second video tu dia lebih kepada shallow foundations. Video nombor 3 dan video nombor 4 tu lebih kepada deep foundations. So watch again video 3 and video 4 untuk lebih pemahaman berkaitan dengan konsep, the theory of the deep foundations, and then the estimations of ultimate bearing capacity of the piles. Okay, this will be my end lecture for topic 2. So next week we'll be taking by other lecturer, iaitu Madam Siti Fatimah, and next week juga adalah new topic 3, iaitu slope stability. So I'm taking this opportunity to say thank you and sorry if ada kurang lah dalam tempoh selama 4 minggu I'm in charge for this topic 2. And I wish you all the best for your final exam dan juga for this good CEG 561. So any questions before we leave from this meeting room?
Tak ada, madam.
Tak ada, madam.
Okay, all the best and good luck and Assalamualaikum.
Thank you.
Thank you so much, madam. Thank you, madam.
Thank you,
Thank you, madam.
Thank you, madam.
Thank you, madam.
Thank you, madam.